Hi, how you doing? All right, here we go. We got 11.5 measures of central tendency. The second half of this chapter is going to be a statistics half, so I think those of you who have been hating on the probability are going to like this. It's a little more calculated, and so today we're going to talk about mean, median, mode, and range, the old mean, median, and mode. And then the IQR, you might not know what that is, and then we're going to go back and show you how to make box plots. They say box and whisker, but I think big boys, big girls say box plot, so I'm going to say box plot. All right, so second slide. We're trying to get it in under 15 minutes today, so we're going to go fast. Here are some of the definitions that you probably already know. The mean is the sum of all of them, and you add them all up and divide by however many there are. The new symbol that you might not have seen is this X bar symbol that indicates the mean. The median is the one in the middle, so the very middle element. And right, Sydney, sometimes there's not one in the middle, so then you have to take the two middle ones and divide them and find the halfway point. Okay, so the median value might not actually be an element in the data set. All right, and then the mode is the most lame one. Isn't that right, Jada? The mode is kind of lame, and I think it's kind of lame because I don't think it's very useful. And this will probably backfire somehow on me, but hey, what's up? I'm trying to make it in under 15 minutes. What do you need? Oh, no pie, no. Yeah, Staub's room though. So the mode is the most frequent occurring element. Okay, and then the range isn't on here, but the range is the maximum minus the minimum. Okay, 13 minutes, let's go. Oh gosh. All right, they're going off in here. I pause it. They're going off on Pi Day. It's Pi Day today. Happy Pi Day. I forgot to tell everyone that. So Pi Day 2019. Woot woot! Find the mean, median, and mode of this deer feeder data set for each hour. So there's how many elements in this set is only 7. It's kind of, I mean, we'll show you how it's done, but normally this stuff is for bigger data sets than just 7 numbers. However, if you're finding the mean, which is the X bar, right? So you're finding the X bar. That means you have to add them all up and divide by however many there are. If you add 3, 2, 3, 0, 2, 0, 1, 2, 4 together, I believe you get 5 plus 7 is 12. So you get 12 sevenths, which I believe is approximately 1.7. Double check on my calculator here, and I'll take some time. Gosh, I'm running out of time now. 1.71. Okay, so there's your mean. Remember, the mean is you add them all up and divide by however many there are, right? The median is like the median of the street. That's the middle element in the street. So the median is going to be the middle one. That means we have to organize them from least to greatest. So if I order these from least to greatest, I'm going to have 0, 0, 1, 2, 2, 3, 4. Okay? And there is an odd number of elements there. So if there's an odd number of elements, that means there's going to be actually one element in the middle. That's 2. Maybe in middle school, you might remember doing this. You might remember going, you want to find the median, cross this one off, cross that one off, cross this one off, cross that one off, cross this one off. Yay, there's the middle one. You might remember doing that. Okay, so that might be kind of fun for you guys to go back and do some of that. So 2 is the median. So the median is 2. And then the mode is the most frequent. See, it kind of rhymes. Mode, most frequent, don't you know? So the kind of lame mode is going to have 2 values. There might be more than one. In this case, it would be 0 or 2. It's a tie. It can't be both. I don't know. Whatever. Find the mean, median, and mode of the next data set. All right, let's do another one. There's only 4 numbers in here. That's kind of crazy. All right, add them all up, divide by however many there are. That's going to be your X bar. 15 plus 11 is 26. 26 divided by 4 is going to be 6.5. So 6.5 is your mean. That's your X bar. Okay. Your median is going to be a little different here because we only have 4 elements. So if I rewrite that in numerical order, it'd be 3, 6, 8, 9. Okay, there's no element in the middle, so I have to take the middle 2. Right? If you're like, cross this one off, cross that one off. Oh my gosh, there's 2 in the middle. Okay, then find the midpoint of those 2, or the average of those 2. So the average of those 2 is going to be 7. How do you find that numerically? You add them and divide by 2. 6 plus 8 divided by 2 is 14, divided by 2 is 7. So the median here is 7. Good. And then the mode, the most frequent, the mode is no mode, none. There is no mode because they all occur the same number of times. No, you don't say everything's the mode. You just say no mode. That'd be silly. What if it was 1 through 99? What are you going to say? The mode is 1, 2, 3, 4, 5. You just say no. Just say no mode. All right, find the mean, median, and the mode of the data set at the bottom. All right, we've done this enough. Let's skip that. Okay, so let's go on to the next page here. Here's the box plot stuff. The box plot stuff is going to, have you seen box plots before? I guarantee you've seen them before. All right, good. So it breaks your data up into fourths or quartiles. So we have, in this case, the median, which is the middle of the box. That's right there. Okay, we have the quartile 1, which is the median of the first half of the data. We have the Q3, which is the median of the second half of the data. And then, of course, we got our minimum value and our maximum value. And that is 5 numbers, or 5. They call them right up here, they say 5 key points. All right, and so 5 key points make up a box plot. This talks a little bit about the quartiles. The interquartile range, this is a new one. We call that the IQR. The IQR is the difference or the range between the third quartile and the first quartile. It's the middle 50% of your data. So the middle 50% of your data represents the IQR. All right, let's make a box plot then. Hello. Okay, here we go. The 5 key points is also called a 5-number summary. And in this case, you'll see this data set was organized from least to greatest. All right, and then from least to greatest, they found the median, the middle one. There's an odd number. From there, they broke the data set into the first half and the second half. So the first half is in this box right here. Okay, and there was an even number of elements in the first half of the data set, so we had to find the halfway point between 5 and 6, which is 5.5. The second half, they found the halfway point between those 2 numbers in the middle, because there was 4 numbers, so there wasn't one in the middle, so that's going to be 8.5. All right, so the 5-number summary then includes the minimum value 4, the first quartile 5.5, the median 7, the third quartile 8.5, and the maximum of 10. That makes up your 5-number summary, or the things that you need to make a box plot. All right. So now, can you, if you grab those, can you make a box plot? Yeah. Okay. Well, let's just see here. So we have a number line. You always have to put a box plot on a number line in relation to some numerical value. And we have there a minimum of 4. So start our little whisker at 4. That goes to Q1, which is 5.5. The box starts there. The box goes to 8.5, which is Q3. And then from 8.5 to 10 is the upper whisker that goes from there, and my median was at 7. Okay, so this gives us a picture of our data. Box plots are useful for trying to interpret large amounts of data sets. This is kind of an unrealistic question because there's only, what, 9 numbers or something here? So it's kind of like, well, you know, that's neat. We made one ourselves. But really, you'd want to use some software. And you might be talking about like everyone at NHS or all seniors at NHS, what was their ACT scores? And then you'd want to like break that down and see where's the middle 50% at, okay? And then maybe you'd want to compare that box plot to say like Edina or something and see how you compare with other communities. So that's what you really use this stuff for. The interquartile range is going to be the Q3 value, the range between the Q3 and the Q1. This is the middle 50% right here. So in this case, it would be 3. Okay, so that is how you make a box plot. And sometimes there's little nuances in here that can kind of goof you up. So on the next page, let's make another one, and let's just start from scratch and let's do it ourselves here. So do you want to be the cross this one off, cross that one off person? I don't like that. So I think this is just going to be, is it 15 in the middle or is it 10 to 15? I think it's 10 to 15. Well, I look to the right, I look to the left, and I see there's 4 values to the right and 4 values to the left, and there's 2 in the middle. Okay. It is sketch. You could count them all up and see there's 12, and then you could see there's 12, and you divide 12 in half, and you know that there's not a middle one because it's even, so you know it has to be the 6th and 7th element, or sorry, the 5th and 6th element. Okay, so now we have to find the average. What's the halfway point between 10 and 15? Good, 12.5. That's 10 plus 15 divided by 2. You do that, you get 12.5. Now the tricky part comes in. We have to find the middle of the first half. Well, the dividing point here for our first half is like right there, right? So 10 is included in the first half and 15 is included in the upper half. I don't know if you understood what I'm saying there. So the first half is underlined here in gold, and the second half would be underlined there in gold. And so now they have an odd number of points there. I think I said there was 12 elements here, but there's actually 10. So the middle of the first half, the median of the first half is going to be 3. And we know that because there's 1, 2 to the left and there's 1, 2 to the right. Okay. And the middle one over here is 20. Okay. 1, 2 to the left, 1, 2 to the right. So now my 5-number summary should be complete. I should have my, let's see, let's do this poopy color right here. So we have 44 is my maximum, 20 is my third quartile, my upper quartile, 12.5 is my median, my Q1 is 3, and my minimum is 2. Okay. Well, that's what they wanted us to write here, our 5-number summary. 1, 2, 3, 4, 5. All right, great. So we got 2, we have 3, we have 12.5, we have 20, and we have 44. All right, the interquartile range then, that is going to be the difference between this one and that one, which is 17. And now we can throw down on a box plot. This is kind of a little bit of a crusty number line because we're going to have to figure out how to go from like 0 to 50 or something. So let's just say I start at 0 here and I go all the way over here to 50. I don't know. I'm not going to be perfect about this because I want to go fast. Let's just say that's going to be 25 or something. And then halfway, maybe halfway between there is like 12. I don't know. So let's just do that and we'll just eye it up. It'd be nice if we had a, oh, we're moving that around. It'd be nice if we had a little less lines here, but anyhow, so 2 to 3 is my lower whisker, so it only goes from 2 to 3. So let's just say it's like there to like there. Whoop. And then the box goes all the way to 12.5, so that's going to be like somewhere halfway between there. All right, and then 12.5 goes to 20, that's like somewhere out to there. And then 20 goes to 44, that's like somewhere like way out to there or something. So just kind of ballparking it for this one. We can label this so we're careful. We got 2, 3, 12.5, 20, and 44. So this shows us that the top 50% from 12.5 to 44 is really spread out, right? 44 might be what you consider an outlier. Have you ever heard of that term, an outlier? Yes. Okay, so one way to calculate outliers, yeah, I'm not going to finish in time, so stop counting me down. Outliers, one way to calculate them is to take the median and plus or minus, or plus and minus 1.5 IQRs. Okay, so in this case, let's determine what might you think an outlier would be. 44, let's just see. So let's find our outlier boundary points. So the median is going to be 12.5. And let's do plus or minus 1.5 IQRs. What's the IQR? 17. Ooh, it's going to be close. So 1.5 times 17. What's 1.5 times 17? That's going to be 8.6 is half of 17. So that's going to be 25 point, did I say 6? 8.5. So 8.5 plus 17 is 25.5. Okay, so now this is plus, it's going to be 12.5 plus and minus 25.5. Okay, that's 1.5 IQRs above and below. So 12.5 minus 25.5 is going to give me a negative, 13? So negative 13 is my lower outlier boundary. Well, that's like way over here. And I definitely don't have any points to the left of that, so I'm good there. And my other one is 38. So 38 would be like, I don't know, somewhere in here. And so any element past 38 would be considered outlier. Is it 39? No, it's not. It's 12 plus 25 is 37, plus 0.5 is 38. Outlier territory. So sometimes people will throw those outliers out and they'll just say, these are too far away from the middle. We don't want to consider this with our data because it's skewing our data. Isn't that right, Mr. Eckhoff? Yep, science, applied math. So that one, so we might just say, yeah, you know what, that one we might want to get rid of that one and then recalibrate everything. One more question and then I'll stop the recording here and we'll be done. If you have an outlier, what does it have a greater impact on, the mean or the median? Because those are both supposed to measure the middle, right? And so sometimes if you have a bunch of outliers and you're calculating a mean, you're going to add all these up and divide by however many there are, and you have a really big one, a really small one. That's going to suck the mean towards the outlier. Okay, and that's kind of what happens when you have outliers, is it makes the mean a little less accurate of a measure of the middle. So that's why in those circumstances a median might be the better choice to measure, like, oh, well, where's the middle there? Okay, so the mean has a little bit of vulnerability as measuring the middle if you have outliers. Yeah. Yeah, I don't think it says anything about outliers tonight, but you know, I just wanted to show you one way to calculate outliers, because sometimes it's like, well, how do you actually know if it's an outlier? It's pretty far away, but I don't know, is it an outlier? So this is one common way to determine is 1.5 IQRs above and below the median. All right, one more data set, but we're not going to do it. So here's your assignment. And happy Pi Day 2019. You got 15 minutes of work. Wait, we got a lot of work time here. Yeah, that's a good point. Do that. When you label your assignments, can you label 11.5 and then blah, blah, blah? All right, thanks. Bye.